and the system calls in OS. Let us start with the various structures of operating system. See, there are majorly 4 different operating system structures. The first one is simple operating system structure, and the second is monolithic, and the third is layered operating system, and the fourth is microkernel operating system structure. So let us start with the simple operating system structure. So in the simple operating system structure, actually the user interface functions and application programs are separated, and these application programs are given access to the IO routines. So this is one of the features of simple operating system structure. That means the application programs are given access to the hardware so that they can directly access any hardware. They can directly access the system or the system memory. They can directly interact with the operating system core. So that is the major characteristic of this simple operating system structure. And the simple operating system structure is very simple to create, and it was designed for the single computer or group of computers. And best example for the simple operating system structure is Microsoft Disk Operating System, MS-DOS. So MS-DOS is an example for simple operating system. And if we talk about the MS-DOS structure, there are 4 layers. The first layer is application programs, so which interact or interface with the operating system functions. And the second one is resident system programs. Actually, the resident system programs are those so which allows for multitasking. That means at a time you can execute the multiple programs. That is, multi programs can be simultaneously executed by using this resident system programs. And we also have the MS-DOS device driver. So in this layer, it provides the device drivers for accessing any hardware devices like input and output devices. Next, we also have ROM BIOS device drivers. Here, the BIOS is basic input output stream. Okay, so at this layer, it provides basic input output system device drivers. Say for initializing all the hardware devices. So before interfacing or interacting with the operating system. So this diagram shows the structure of the simple operating system. So if you see at the top of this operating system, you can see the application programs are there. So which actually used by the user. The user uses these application programs to interact with the operating system and to work with any operating system. And below these application programs, below this first layer, we have the resident system programs. These resident system programs are those so which allows these application programs to be executed simultaneously. And it can also have direct access to so these hardware devices. And see, these resident system programs can talk to the device drivers. They can talk to the hardware devices through these DOS drivers. And at the lowest level, there are ROM BIOS drivers, so which are actually directly interfaced with what? Hardware devices. That means IO devices and the hard disk storage devices. See, the ROM BIOS drivers have, so they are used to communicate with the hardware devices like the storage devices and all the IO devices. So if you look at this, the structure of this simple operating system, the application programs are given access to the hardware devices directly. They can directly interface with, they can directly interact with the hardware devices of the system. So that is one of the advantage and as well as the disadvantage. And we will see how that is a disadvantage in this case. See, if you talk about the advantage and disadvantage of simple operating system, See, the first advantage of simple operating system is since there are only few layers, since there are only few components in the simple operating system, only application programs and the user interfaces. So it is very simple and a smaller operating system to create, and it has limited interfaces. Okay, since it has limited interfaces and it is very simple to create and easier to create, and it also provides the applications with the higher performance because there are only few components. See, here you no need to travel through the multiple layers when it is compared to the other operating system structures. There are no multiple layers. There are only two layers. The application programs can directly talk to the hardware devices. So there is no intermediary levels since there are no intermediary level or there are no intermediary components. So it provides the services at high speed. So these are the two advantages with the simple operating system structure. And however, there are disadvantages too. So when we discuss these disadvantages, the first disadvantage is since the application programs can access directly the hardware devices. This is one of the drawback with the simple operating system. So because the application program, if there is any crash, if the application program failures, the entire operating system leads to failure. So that is one of the drawback with the simple operating system. And see, and the low level abstraction, that means here the data hiding is not achieved. This means the application programs can directly access to hardware. So here any malicious software or any malicious program can directly access the IO routines. They can directly access IO routines and they can directly make harm to the system. There is no data hiding feature. That means it is not at all secure. These are the two. These are some of the disadvantages with simple operating system structure. Okay, so let us move on to the second type of operating system structure, that is monolithic. See, the monolithic operating system is also known as monolithic kernel. See, actually the monolithic kernel is nothing but, so it is the component which combines all these functions together. See, it combines all the functions like file management, memory management, device management, process management are actually combined into this single monolithic kernel. That means there are actually two levels in this. So one is the user interface, and so second one is monolithic kernel. The monolithic kernel actually combines all these basic functions like file management, memory management, device management, process management, and all are combined into this single kernel. Here the kernel is responsible for providing all these functions, and all the resources of these operating systems are actually present in this monolithic kernel itself. See, it was first used in 1970s, especially in the Unix operating system. And so it was used to perform a very smaller task like batch processing and time sharing tasks, especially for the bank-like industries. So that means the basic idea behind this monolithic operating system was the kernel. That means the kernel is the only component which is responsible for providing all the basic functions of operating system. So just look at this diagram. See, in this monolithic kernel system, at the top level, there are applications. These applications are actually used by the user. So through this application, the user can access any of these services. But if the application has to access any of the operating system services, first it has to interact with what? Monolithic kernel, because monolithic kernel is the only one which provides all these services. Which kind of services? See, file system, it provides the file system, network subsystem, and memory management, and everything is provided by the monolithic kernel. So that means there is no opportunity, there is no chance to there is no chance for an application to directly interact with the hardware. So in between the application and the hardware, so there is another component that is monolithic kernel. The monolithic kernel combines, see, all these services. So which services? So file management and memory management, process management, and all these drivers are actually controlled by the monolithic kernel. See, this is unprivileged mode. That means the application programs are actually unprivileged. Unprivileged in the sense they do not have any rights. They do not have any access privileges to hardware. So if they want to use the hardware, they must interact with this monolithic kernel. The monolithic kernel then provide the access to hardware, and the hardware responds back to the monolithic kernel, and the monolithic kernel then responds back to application layer. This is how the monolithic kernel system works. That means, so instead of providing the direct access to application programs, we are combining all these the operating system functions into a single component called as monolithic kernel. The monolithic kernel is responsible for providing all this basic function of the operating system. So that is the structure of monolithic operating system. So let us see the advantages and disadvantages. See, when we talk about the advantages, again, it is very simple because there are few layers. There are few layers. One is the top layer, that is application layer at the top level, and below that we have the kernel layer, kernel level. So since there are only few levels, it is very simple and easy to implement and easy to develop. And it also gives the higher performance because with a few levels of layers or few levels of components, so it automatically provides the high performance because these applications, if they want to interact with any hardware, there is only one middle layer, that is the micro, that is only the monolithic kernel. So there is only one monolithic kernel. There is only one level in between the application and the hardware. Obviously, the performance is greatly improved. And apart from these advantages, it also has some disadvantages too. So let us see what are the disadvantages with the monolithic operating system. See, if you want to add any new feature or if you want to make any modification, which is very difficult because all the functions are combined into the monolithic kernel only. So if you want to add anything, you have to add that to the kernel, but it is very difficult. It is very complex. Okay, we are combining all the basic functions like file management and memory management. Okay, so if you add anything, it may affect other service also, other function also. If you make any change, it also affects another function also. So that is why adding new feature is very difficult in this case. And however, it is very so that means there is a protection problem also. See, there is a low security problem. See, the function since the functions are combined into only one level, that is kernel level. Again, there is a security issue. Okay, so let us see the layered operating system structure. This is the third type of structure of operating system. So in this way also we can modularize the operating system. See, the name itself is telling us how the operating system is modularized. So in this structure, in this type of structure of operating system, the operating system is modularized by dividing that operating system into number of layers from level 1 to level n. That means the operating system is divided into number of layers, where each layer is responsible for providing one specific task, one specific function. Okay, just look at this, how the operating system, the layered operating system is divided into a number of layers. See, and at the lowest level, the layer 1 is actually responsible for providing the hardware services. And above that layer 1, we have layer 2, which is responsible for CPU scheduling CPU scheduling. And then above that layer 2, we have layer 3 that is responsible for memory management. And above the layer 3, we have layer 4 that is for process management. And above that, we have IO buffer management, that is device management. So, and at the top level, we have the user programs. That means the user interface and application programs are at the outermost layer. Okay, the outermost layer is the outermost layer provides what? This user interface services and application program services. That means if at all the user program or any user wants to interact with the operating system, and if they want to do something with the operating system, must be the request must transit through all these layers one by one, right? So first it should travel through the layer 5. That it means a see that IO buffer level, that is which is responsible for device management, and it must travel through the next level, that is process management level, and then it should talk to the CPU scheduling level, memory management level, and then it reaches the hardware. So there are multiple layers in between what the user programs and actual hardware. So this is the layered architecture of operating system. Okay, so let us see the advantages of the layered structure of operating system. The first advantage with this layered system architecture is modularity. That means we can modularize. Here we are able to divide the operating system functions into the number of modules. That means each module is at one level. So we are dividing this operating system into a number of modules by dividing that operating system functions into number of layers. That is a modularity. And easy debugging is another advantage with this layered system architecture. See this, what is this easy debugging? That means if at all you want to make any change, or if you want to fix any error at a particular layer, so you can easily do it because it doesn't affect any other layer because all the layers are separated. All the layers are separated. So if you make any changes to one layer, if you make any change to one layer, it may not affect another layer. So this is debugging. The debugging will be very, very easy. And easy update. See, here the update in the sense if you want to add any features to one layer, so it may not disturb any other layer because all layers are separated and every layer has its own functionality. There will be no interfere with any other layer. And see, there is no direct access to hardware. So when it is compared with the first type of the structure, that is simple operating system structure, in case of simple operating system structure, the application programs can directly access the hardware, but here there is no direct access to hardware. So if at all the application programs want to access the hardware, it has to, the application programs have to go through the multiple levels, then only the request will be sent to the hardware. That means the application programs cannot harm the hardware device. It may not lead to the system crash. And the next one is abstraction. The abstraction is, see, hiding. Here, the hiding is nothing but the implementation details or hardware details are unknown to the application programs. The application programs, since the application programs cannot directly see the hardware, cannot directly talk to the hardware. So the data hiding is achieved. It is greatly achieved in case of layered architecture, the layered structure of operating system. So these are the advantages of layered structured operating system. And however, there are some disadvantages too. So let us see what are the disadvantages with this layered structured operating system. Okay, so though there are multiple layers and which are responsible for performing the different functions, it is very complex to implement. So if you want to implement all these functions, It will be very, very complex because every layer interacts with another layer. For example, the topmost layer, the application layer, talk to the next layer, which is IO buffer. IO buffer. That means if you are making any change to one layer, it may affect the below layer because these layers are arranged one that is top of one layer, there is another layer, and at the top of another layer, there is another layer like that. They are placed one over other. So the implementation will be very, very difficult. That means if you make any change, you have to take care that whether it is affecting the below layer also. And see, the second disadvantage with this, the layered structured operating system is slower in execution. Why? Because if the application program wants to perform any operation using the operating system, for example, using the application program, the user wants to create a file. If he wants to create a file, he can not directly talk to the hardware. So he has to send a request to the below layer, that is IO buffer, and then IO buffer will talk to the CPU scheduler, and then it will talk to the next level, and then the request will pass to the next level, and finally it reaches the hardware. So this takes a lot of time for reaching this request to hardware, and response should come back to the application program. That means the execution process will be slower in case of this layered structured operating system. And the next one is functionality. What about the functionality? Though all these functionalities are separated into the different layers, we cannot divide all the functionalities. Some functionalities should be mixed up. Some functionalities must be mixed up to serve the user request. Some functionalities may be interrelated. They can't be separated. This is again disadvantage. And the next one is communication. See, the communication is possible only between the adjacent layers, but between the non-adjacent layer, there is no communication. For example, here the IO buffer cannot directly talk to the hardware. Here the CPU scheduling algorithm cannot directly talk to the hardware. Your application program cannot directly talk to the hardware. That means there is no direct communication is provided between the non-adjacent layer. This is one of the drawback with the layered system architecture. So these are the some of the disadvantages with layered structure of operating system. And let us see the another structure of operating system, that is microkernel operating system structure. See, in the microkernel operating system, we combine some non-essential components into one unit called as a microkernel. That means some of the user level services are combined into another component which is called as microkernel. So the smaller kernel contains actually the non-essential components, so which are not required uh, in case of in case of the kernel. Okay, the smaller kernel is actually said to be microkernel. See, for example, just let us go back to the previous structure of operating system, that is in the layered operating system. In the layered operating system, we are combining, see, we are dividing all these functions like the file management and every process management and memory management into different layers. Okay, so but in the microkernel operating system structures, and some of the non-essential components, okay, especially the user programs at the user level and some of the system level actually combined into one smaller kernel, which is known as the microkernel. Okay, so the benefit with this microkernel operating system structure is, if you talk, if you want to add a new service, if you want to add any new service, the new service can be added to this microkernel instead of adding the actual kernel. That means the actual kernel actually contains only the essential components, so which provides only the essential services. So in this way, we can secure the actual components and which are essential for operating system. So here the microkernel contains only the non-essential, and if you want to add any new service, the new services can be added to. So this microkernel only. So in this way, we can protect the actual kernel. We are not disturbing the actual services and the core of this operating system. Next, if any service fails, that means by adding any new service or by making any modification to this microkernel, and if there is any fail, and if there is if something went wrong, it doesn't affect the actual operating system. It doesn't affect the actual operating system. So this is the main advantage with the microkernel. In the microkernel is the actual kernel is separated into the two separate components, you can say. So one is essential and another is non-essential components. That means the microkernel is divided into two parts. The one part contains essential components and another part contains non-essential components. And see, if at all you want to add any new service or if you want to make any change, the changes are actually added to the microkernel only, which is non-essential. And if there is any fail or if there is any crash, it doesn't actually affect what? The actual kernel. So this is one of the advantage with the microkernel operating system. So just see the advantages here. So it allows the operating system to be portable across the platforms. That means you may implement this microkernel operating system on various machines. So because there is a microkernel and the kernel contains actually the standard components which are essential, which are common for any platform. And whereas the microkernel is a specific, the specific components and any new features which are required by a particular platform can be added. So the advantage with this microkernel is it is portable. You can implement it on any kind of machine. And it can be effectively tested because microkernels are very smaller. Okay, so it is very smaller. So you can easily test and you can easily implement it. So these are the two advantages. And there is one disadvantage too. So when we talk about the performance of this microkernel operating system structure, so it suffers with the performance. Why? Because there is a intermodal communication because the application programs cannot directly talk to the hardware. First, it has to talk to the microkernel, then the microkernel talks to the kernel, then the kernel talks to the hardware. So because of this intermodal communication, automatically the performance will be degraded. This is another disadvantage with this structure of this operating system. Okay, and there is another approach, modular approach. There is another approach, modular approach. So this is another way of modularizing the operating system for the simplification of the operating system. Since the operating system is a complex software, it must be modularized, it must be divided into some simpler components. No? So another approach for modularizing, another approach for simplifying the operating system structure is modular approach. See, in this approach, what we do is we actually design the operating system with the help of some object-oriented programming techniques. So we use some object-oriented programming techniques to modularize this operating system kernel. So you can compare it with the layered structure. where each layer is responsible for providing some specific function. And see, in the modular approach, the kernel contains only the limited number of basic components, and extra are added. The extra services are added to the kernel as dynamically. That means we do not include all the components in the kernel. So if any module is needed, if any service is needed, any feature is needed, that can be dynamically added in the modular approach. So that is one of the basic characteristic of modular approach. Okay. So in the modular approach, what we do, the kernel actually contains only the essential things, the essential components. And if at all the new service is to be added to the kernel, that can be added dynamically. That can be dynamically added, that can be dynamically loaded. See, these are actually available in the form of modules. These are actually available in the form of modules. So these modules can be dynamically loaded at runtime. So that means at boot time, they can be dynamically added. That is one of the uh, characteristic of this modular approach. See, we have an example for this model approach uh, operating system structure. So we have an operating system called Solaris. In the Solaris operating system, there are 7 types of kernel modules. They are scheduling classes, file systems, loadable system calls, executable formats, stream modules, miscellaneous modules, device, and bus drivers. So like this, these are 7 types of modules are there. So these modules are loadable at a runtime based on the necessity, based on the requirement, they can be loaded. So that is the modular approach. In the modular approach, these modules, that means any required module, can be added to the operating system kernel as we demand. But these modules are added dynamically in the sense during the runtime. During the runtime, that means at boot time. That is a modular approach. Okay, signed up. So in the modular approach, when the operating system is structured at the topmost level, there will be a top layer which provides the application, which provides which provides the application environment. That means the user interface is provided at the top layer. So which is responsible for providing the user level services, user interface services, which will actually talk to this the next level layer, so which contains all these modules. The below layer provides what all this kernel environment, where the kernel environment is loaded with these dynamic modules and the basic modules. So as we have already seen, it contains some standard components, that means the essential components, and apart from the essential components, some dynamic components can also be added. That means dynamic modules can also be added at boot time. Okay, so these are all the different modules which can be added to the operating system kernel at a runtime. So scheduling classes, this module can be added to the operating system kernel at runtime. Similarly, the file system, loadable system calls, executable formats, stream modules, miscellaneous modules, and device and bus drivers. So these can be added to the Solaris kernel on demand. That means as per our requirement at runtime. So these are the different ways of modularizing the operating system. Thank you. So this is this session. So in this session, we have seen what are the different ways of modularizing the operating system, the various structures of operating system. So I'm ending the session. Thank you.